Okay, so let's have a look at this co-integration question. So which is from 2002, step 1, question 7. So let I equals to that, and let j equals to that. And this question demonstrates a really standard integration technique, which I hope we learn from this. Yeah. So by considering I plus j and I minus j, show that 2i equals to a plus ln sine a cosine a. Fine. So, well, if it tells you to consider, you do it, right? So I plus j equals to what? I plus j equals to integrate, and you see that it cancels, yeah? So this becomes 1 dx, yeah? Because the top becomes cosine x plus sine x, right? Cosine x plus sine x, and it cancels with the denominator, yeah? So this becomes a. Sweet. How about I minus j? I minus j, let's write the whole thing out, equals to cosine x minus sine x. Okay, and we see that the top, what is the top? The top is the bottom, but differentiated, right? If you differentiate the bottom, you get the top. Yeah, so this is called a derivative present integral, right? That's how I call it. So this becomes ln of what? ln of the bottom, yeah? Sine x plus cosine x. Yeah, and you can check by differentiating this, yeah? You'll get the thing in front. That's called derivative present, right? So this is a naught, and when I put in 0, this is 1, right? So ln of 1 is 0. Yeah, so I'm left with ln of a plus, ln of sine a plus cosine a. Yeah? Sweet, okay. So, show that 2i, right? How do I get 2i? Well, I just add these things up, right? So I have I plus j plus I minus j equals to a plus ln sine a plus cosine a as required. Yeah, first part is lovely. Okay, this is a very good technique. So find also from 0 to power 2, this time I have p and q's. Okay, well, we do the same technique as above, right? The cosine was the I, so, let's let this as I. Alright, and we do the job again. What do you think the j should be? What do you think the j should be? Well, the j is just a sine version of this, essentially, right? J is... So keep the same limits, though, yeah? Keep the same limits. If not, you can't combine things. So I have sine x over p sine x plus q cosine x. You need the same denominator as well, right? If not, it doesn't work. Okay, so let's try to do the same thing. Now, I want the I plus j to somehow give me 1 dx again. And obviously this time it doesn't work, right? Because I have the p's and q's in front, so I have to adjust. So how do I adjust? So I adjust it by saying, okay, well, if I consider qi plus pj, then that is okay, right? That is absolutely fine. That will give us what I want. Yeah, that's the addition bit. For the addition, I always want to get something which is in the form 1 dx, right? That makes me happy because that's pi on 2. Okay, now, the next thing was the I minus j bit. Think about what happens when I differentiate this, right? I want the differentiated form of this. So if I have pi and then, minus qj, that equals to what? That equals to the ln of the bottom, right? ln of the bottom plus q cosine x pi on 2 to 0. Yeah, so the I plus j, I minus j, for the I plus j, you want to cancel out the top and bottom. For the I minus j, you want to make the top the derivative of the bottom. Yeah, that's essentially the idea. Okay, and now let's just solve this. So if I put that in, what does this become? So if I put in the pi on 2, this becomes lnp minus lnq. Yeah, I suppose it should be. Okay, good. So now I'm left to solve really annoying simultaneous equations. So I want to find I, right? I want to find I. So let's go, let's multiply the whole equation here by q over p, I suppose. Okay, q over p. So, okay, maybe not. Let's go p over q instead. P over q. Okay, so now I have p squared over q I minus pj equals to p over q ln p minus ln q. So now I have, so consider these two equations, I add them, so now I have p squared over q plus q I equals to pi on 2 plus p over q ln p minus ln q. Okay, I mean for step questions you just have to take care of the algebra. There's no way out of this. So maybe multiply the whole equation by q and then just divide plus p times lnp minus lnq, just to make it look prettier, over p squared plus q squared. Lovely. Okay, good, fine. So let's move back to the top. Let's look at part 2 then. So from 0 to pi over 2, now this time I have cosine x plus 4 instead. And for the denominator, I have that 25 there, which looks slightly irritating. Okay, so again, I choose this as my I. Let's think about what the j should be. Okay, so again, I want the I plus j to be the same as the bottom, right? So now, if I have to make the same as the bottom, the first thing is that I need 4 lots of I. I need 4i, right? I need 4i because I need to cancel out the 4 cosine x. Okay, so if I have 4i, then I've already got the 4 cosine x plus 16. Right? So what I'm left with is 3 sine x plus 9. Okay, so what is the natural selection of j then? Alright, well then the j has to be, we want 3j really, right? So this is sine x plus 3. This is symmetrical to this bit, right? Yeah, so this is over 3 sine x plus 4 cosine x plus 25. Make sense? Yeah, that's how we choose the j. Right? Just by thinking of, okay, I plus j, I need the top and bottom to be the same. Right? Okay, now I erase stuff, and you think about how to do it when I erase this thing. Right? So I have, so I considered the plus case. Does the minus case work out? Think about that. Does the minus case work out? Okay. So, what have I got? So I want 4i plus 3j, right, as I mentioned. Then that becomes 0 pi over 2 of 1 dx, which is a pi over 2. Yeah. Okay, now, how about the minus case? So if I differentiate the bottom, notice I have 3 cosine x minus 4 sine x, right? Okay, so what is a sensible thing to try? Let's go 3i minus 4j, right? 3i minus 4j. And indeed, that is 0 pi over 2 of what? Of this thing. It actually works out. The 12 and the 12 cancels out, which is really pretty, I think. One of the prettiest results I've seen. So over whatever the denominator was. So plus 4 cosine x plus 25 dx. Right? And we know how to integrate that. Right? We know how to integrate that. So again, let me erase this. So it just becomes a classic ln, yeah? Just becomes a classic ln. So this becomes ln of 3 sine x plus 4 cosine x plus 25. And you go from pi over 2 to 0. Okay, why is this not erasing it themselves? Okay, there we go. Alright, and you evaluate. So when I have pi over 2, the cosine becomes 0, so I have ln 28. And when I put a 0 in there, the sine becomes 0, so it becomes minus ln 29. Okay, and again, simultaneous equation chart, right? So what should I do? Let's multiply the second equation by 3/4, I suppose. So now I have 9 over 4i minus 3j equals to 3/4 of, let's write it in one fraction, because I can't be asked to write so many things, 28 over 29. Okay, so again, add the two equations here and there. So now I have 25 over 4i equals to pi on 2 plus 3/4 of ln 28 over 29. Okay, God's sake, how do I do this? So I, and then that times 4 over 25, right? So that's 2 pi over 25 plus 3 on 25 times ln 28 over 29. Sweet. Lovely. Hopefully I didn't make a slip anywhere. Okay, correct it yourself, right, if I did. Good. Okay, so this is quite a pretty question, actually. All right, I really hope that we learn this integration technique. If one day we're given an integral, let's say an integral in part 2, without the guidance in front, I hope that we could also still manage using this I plus j and I minus j method. Yeah, it's really cool. Lovely. All right. That's about it for the question, I suppose.